Patrick Cook here. Welcome to session number 30 of the Mastering Mandelbulb 3D Formulas tutorial series. Now, in the last session, in session 29, I introduced the whole concept of the DEcombinate sequences. All right. In DEcombinate, you are combining, using volumetric Boolean logic, you are combining two sequences. Don't think of it as combining multiple formulas. Think of it as combining multiple sequences. All right, and as I pointed out, this value right here, all right, is telling the Mandelbulb 3D application where the demarcation point is that indicates what the first sequence is and the second sequence. You only have two sequences. All right, you got one before the demarcation value and one after. Okay. All right, now let's set something up here. I'm going to do a reset. Get back to DEcombinate. It's reset to 2. That's your default value. I'm going to put in formula number 1. I'm going to put in a comma IFS. If I want to look at it, if I want to see what that shape looks like, I go back to alternate and run it. Because I can't run a DEcombinate with only one formula sequence. But in alternate hybrid mode, I can run one formula at a time. I'm just going to move that over so we can see it and recalculate it. Okay, good. All right, I'm going to go back to DEcombinate now. And I'm going to go to my second formula, and I'm going to do the box because we know what that looks like. Calculate it. Okay, good. So the box and what's this first one I did here? The comma IFS. The box and the comma IFS are intersecting right here. All right. And because I have this set on min will essentially show all the objects whether they combine or not. All right. Let's set that to max. Let's see what happens. Okay, good. Max, it's only going to show on the screen the portions of the graphics that have actually combined. All right, and let's go over to mix. All right. All right, yeah, now this is showing where the two fractal objects are mixing together. All right, let's get back over to min, because in min we can always see all the objects on the screen at the same time, and that's kind of makes it possible for us to understand what's going on here better. Okay, now you know that I have two sequences. Formula 1 and Formula 2, those are two separate sequences because I have that demarcation set to 2. Now let's go over and let's set up another No, I'll tell you what. Let's throw an escape time in there. Why not? Okay. Let's go over and let's put an axion C in position number 3. Let's calculate it and see what happens. Oh, formula option is not valid. Interesting. Okay. All right. So this is telling me that I can't have an escape time in the DEcombinate when there's another diff. All right. But we know from a previous session that we can have 2 or more escape time. But this is showing us that we can't mix dIFS and escape time in the DEcombinate. All right, fair enough. So let's do a pyramid. All right. I don't really see the pyramid anywhere. All right, let's pick something else that we can see. Okay, how about miter IFS? No, we're not seeing that either. Okay, let's try. Oh, columns. We know columns. Okay. All right. Let's see if maybe the columns is over here. There's the columns. Okay, good. All right, so I've got a scenario set up here now where I've got 3 dIFS. All right. Okay, now we're ready for the next concept here. Now that we understand that we have 2 sequences in the DEcombinate because of the demarcation of 2, my first sequence is formula 1. My second sequence is formulas 2 and 3. All right, you got that part? All right, we're good. All right, now let's turn our attention down here. We see we have Maxits hybrid part 1 60, and I got a Maxits hybrid part 2 60. Now, if you recall, way back in an earlier session, I'll put it up on screen, the session number, I'll put it up on screen. We were talking about the min and the max iterations. All right, we were in alternate hybrid mode at that time. And you remember now, I was explaining that min iterations is the minimum number of times that the whole formula sequence, all right, the sequence or the set, it's the minimum times that the whole set would iterate or run or execute, all right? I am not talking about the iteration count up here right now. That's the iteration count of the formula itself. These iterations down here are of the set, all right, or the formula sequence. All right, so you'll note here that when I'm in DEcombinate mode, I have minimum iterations like I always have. I also have Maxits hybrid mode part 1, Maxits hybrid part 2, okay? Those are new values that only show up when I'm in the DEcombinate hybrid mode. Now, what those mean, I'm going to explain what they mean, and then we'll pick it up again in the next session. What those means is that is the maximum number of iterations that will occur for the 2 parts or the 2 sequences of the DEcombinate formula definition. All right, we know we have a demarcation of 2 up here, a 2, and so we know sequence 1 is formula 1, sequence 2 is formula 2 and 3. Well, they're calling it parts, we could call it parts 2. So part 1 is this value. That's the maximum number of iterations that will occur for the DEcombinate formula sequence number 1, or the first one. This is the maximum number of iterations that will occur for the second DEcombinate formula set or sequence or part, which we have set up here as 2 and 3. All right, if I had a fourth, let's get a fourth, I don't know, let's try that one, see what that looks like. Here we go, something's happening. There we go. Okay, there's my columns. There's my columns in there. There's my cube. And I just put a tiling IFS as a 4th formula. Now I'm going to set this at 3, which means that my DEcombinate set number 1 is formulas 1 and 2. My second DEcombinate set is formulas 3 and 4, right there. Okay? All right, in the next session, we're going to play with these Maxits down here and see what the impact is on our graphic. All right? All right, I'll see you in the next episode.